channel. We'd love to hear from everyone who's trickling into the audience. We're going to be speaking about the future of batteries when everything's electric very shortly. That's where you've come. You've come to the right place. We'd love to hear from who you are. Put your name and your geography and your company into the chat channel. This is meant to be an interactive discussion, so we'd love to hear from you, and we'll start in just a couple minutes. Hello, Molly, and hello, Shauna. Thanks for tuning in. Hello, Wendy. All right, I'm going to kick us off. We're going to start this officially. All right, we're going to be talking about the future of batteries when everything's electric. The idea that the mass adoption of electric vehicles and clean energy will rely on low-cost, reliable energy storage. And I think everyone who's probably tuning into this session knows the cost of lithium-ion batteries has dropped really dramatically in recent years. But new battery innovation is still going to be required to help bring the cost down even more, and also to create new types of batteries that have more power, more safer, have different new interesting features. And so this conversation is going to be about what are the batteries that we need today and tomorrow to electrify everything. So I'm joined by a great group of panelists here. I'm going to start off by giving some brief introductions, and then we're going to jump into moderated Q&A. If you look on the side, you probably all see the chat channel there. That's where you can interact with us. You can send us questions. And so we'd love to hear from you. I have one slide that I'm showing right now. If it's really big on your screen, you can double click on it to make it a little smaller box so it won't take over your entire screen. All right. First up, we've got Asim Hussain. He's the CMO of QuantumScape. You might have heard of QuantumScape. It's a battery startup that has had big success recently, and Asim is going to tell you a little bit more about that. We've got Kelty. He's the VP of Automotive for Sila Nanotechnologies. They're also a battery materials startup, a local one that has also had great success. So Kurt's going to tell us a little bit about that. And then we've got Dustin Krause. He's the director of e-mobility for Volkswagen of America. And I know everyone knows the name Volkswagen, but they've been doing a lot of interesting things around battery innovation. Who knew? Battery innovation and battery manufacturing. So I'm going to start off the conversation by asking the three of you. So batteries to power both EVs and clean energy are having kind of a big moment right now. I tuned into the VW Battery Day. Tesla's has their battery days. Batteries are a big topic right now. How are batteries enabling this clean energy revolution, kind of from a high level? Asim, why don't we go to you first?
Sure. First of all, thank you for having me. Thrilled to be in this session. I think if we think about batteries at the highest level, and we think about the sectors that are responsible for greenhouse gas emissions and how that's playing out, transportation is about 25%, and then electricity generation, call it 25 to 30%. And in all of that, if you're going to electrify, given that electricity is typically balanced in real time today versus needs to be stored in order to bring more renewables and others online. So starting with the electricity sector, you have that. But at the same time, if you're going to electrify transportation and you only have 3% penetration, call it today, in transportation, how are you going to get the mass market adoption in transportation such that even if you have that renewable power to enable it? So at the highest level, if we look at the problem, we have to electrify transportation as well as have energy storage from a stationary perspective to enable renewables penetration both in order to get better and better. there's one step that gets better from the standpoint of if you have more efficient generation plants that are charging electric cars, you're going to get one step in terms of greenhouse gas emissions reduction. And then as more renewables get online, you'll get a much broader impact. So batteries are an enabler across, both those massive areas to reduce greenhouse gas emissions.
Yeah. Why don't you tell us just a brief bit about QuantumScape while you have the floor?
Sure. So QuantumScape, look, what we're trying to do is Lithium Ion Technologies has been here for 30 to 40 years. At the same time, those batteries, in terms of their capabilities, were essentially adopted from consumer electronics to EVs, right? And from QuantumScape's standpoint, what we're trying to do is create a next generation battery that essentially increases the energy density and changes the dynamics so you can charge the car faster, it can go farther, and is going to have a greater life. So super quickly, while you have this diagram up, if you look at a traditional lithium-ion battery on the left, it's going to have an anode and a cathode, the cathode being at the bottom, the anode at the top. The anode typically has graphite or silicon in it, or some combination, and it has a porous separator, and there's a liquid, that electrolyte, that flows through the entire piece to enable you to transition lithium ions. What we're trying to do is dramatically reduce the size of the battery and plate the lithium as a solid layer over a solid state separator that combines with the cathode. So at QuantumScape, this is the technology that we're pioneering and bringing to market. And with the lithium metal plating, we can go through some of the benefits in more detail later, but essentially it allows you to get rid of the anode altogether. So you're getting rid of the manufacturing aspects. You have a solid state separator, and you can move the lithium ions up and down in the battery a lot faster. So you're going to get faster charge, and you're going to have much more space for the battery, so you're going to get greater range. So those are some of the aspects that we're trying to bring to the market, such that the total cost of ownership for a vehicle as well as is reduced, while the performance is enhanced dramatically.
Gotcha. I'm going to move us over to Kurt. I'm going to do the same kind of high level question for you, kind of how are batteries like enabling the EV and clean energy revolutions, but also would love your take on Sila and Sila, and make it help us understand kind of the innovation there that's at the core of the battery.
Yeah, so answer your first question, I mean, how are we helping, or how are batteries going to help the transition to a clean energy economy? Let's just focus on EVs first, because I think that's going to have the biggest impact, getting everybody off of fossil fuels and onto EVs. The big thing, the batteries decide so much of the vehicle. First of all, the cost. I mean, roughly 40% of the cost of a car is in the battery. So anything you can do to reduce costs is going to have a huge impact. Performance is also determined by the battery. You've got whether it's the handling of the vehicle, because you can make a smaller, lighter one, you can get better handling from that. It determines the driving range, which is the big marketing attribute of how many miles you can drive. The cabin space, it's also determined by it, and by your battery. So it's just so many aspects of the vehicle that are really determined by the battery. You've got to, as an OEM today, you really go deep in the battery chain. I'm sure Dustin will touch on that later. So the battery has this a massive impact on enabling EVs. But that's the answer to your first question. The second part of it, just talking about Sila, very, very briefly, based in Alameda, California, we started about 10 years ago and make a black powder, and that black powder is silicon anode material. We sell it to battery cell manufacturers. We do not make battery cells. We are a material supplier to the industry. And what does our material do? Well, it enables an energy density increase of about 20%. You get big increase in energy density. It's a material that is available today. We sampled it with multiple partners, and they're getting great results from it. It's something that is available with commodity materials, the raw material inputs available around the world, and the big thing is it's a drop-in replacement. So all the investment that's going into factories right now around the world, nothing needs to change. Same equipment, just change from graphite over to to our material. And what makes us stand apart aside from those four things is really it's we've developed a silicon material. I mean, silicon's been around for a couple of decades now that companies have been working on it, and there's silicon actually in the Tesla vehicles today, made by Panasonic, the cells there. But it's only a couple of percent of silicon, and the reason for that is there's a swelling issue that's associated with silicon. And what we've done at Sila is we've solved the swelling issue, such that instead of putting a couple of percent in, you can actually replace the graphite completely. Use 100% of our material, replace the graphite, get this 20% increase in energy density, and with existing factories as a drop-in replacement.
Thanks, Kurt. Dustin, let's hear. I mean, we know VW. We know VW is investing a lot in electric cars, and super excited to see all the things coming out from the company. What's your take on how batteries are kind of enabling this transition, and also how VW is looking at battery innovation and manufacturing?
Of course. I think it's our responsibility to bring these things to life in a real product, right? You can have innovations with battery technology, but we have to put them in a product that's going to make them desirable and people want to adopt these technologies overall. So that's really where we come into play, is how do we use the battery technology in a product to actually get people to adopt a clean energy product. So I think what's important is the vehicle, I think, is going to be a really important tipping point to people thinking more sustainably overall. If we can get folks to adopt to an EV, they'll start to potentially think about other areas of their life to be more sustainable too. So it's really a tipping point. And I've been in the electric vehicle, in particular, in electric vehicle, space for a better part of like 13 years, and that's, I think, what we've seen. Is that somebody starts with an electric car and then they adopt that to solar panels and battery storage at home, and the battery is going to be central to many of those things. So we think that's important. Now, you have to do that by solving multiple issues, and that's something that VW can do. First off is, how do you get into a price point that I think that the scale of a company like VW can bring to this, really build vehicles globally. Second thing is, how do you work with partners and internally to get the kind of range that I think people are looking to, really replace an internal combustion car, because it's still a big concern for many consumers. And the third thing is, how do you solve this charging piece too? Because you could get, a huge amount of the population into an electric car, but those people have to have garages and other things right now. So how do you solve the longer tail of this? Is, a lot of in major cities, people have to park on the street, and other places. How do you solve those problems too? And we're really working on all dimensions of this to make sure that we can get mass adoption of electric cars, which in turn we think will have great effects, certainly on the environment because of what we were doing in transportation, but then be the tipping point for other technology as people look to adopt a more sustainable future overall.
Yeah, how is VW looking at battery innovation and manufacturing? It looks to be a large investment and a big area for the company.
Well, we have to look in the future what our customers are going to demand. And when you look at Volkswagen, we want to be a leader. We are one of the largest automakers in the world. We're always vying for first or second place. And as we see this as a competitive advantage. So as we want to, continue down this road, we've got to think about cost. We've got to think about supply chain. We've got to think about desirable vehicles that people are going to want to buy, and we're going to have to be able to figure out how to deliver those to those folks. So that's why this is here. We want to stay competitive, and we think this is where the market is going. So that's why the investments go that way, and we're fully committed.
Great, thank you. All right, I'm going to stop screen sharing that. And I'd love for the audience, if you have questions, please put them in the chat channel. There's also a little Q&A channel. I see there's a couple questions in there coming up, but we'd love to hear from you. I think the next question I want to ask is, so lithium ion batteries are obviously dominating today in terms of electric vehicles. They're providing the power that we need. The cost is coming down dramatically. Are they good enough to power the future that we need? Why and why not? Austin, I'm kicking that to you first because I think I know your answer.
Sure, they're absolutely not good enough. There's a reason why we're at 2 to 3% penetration, and the cost structures are where they are today. It's been a massive effort by the industry. and the OEMs to utilize what's existing technology for lithium ion. But a few percentage points of cost reduction a year is not going to drive mass market adoption. So if we think about it from that perspective, and then it's not just about cost, it's also about performance. I mean, Dustin already touched on sort of the critical issues are how fast can you charge that car. If you're competing with a combustion engine, you want to be able to get down to less than 15-minute charges, really to, ideally to the gas station experience of today in some form or format. And the other aspect is the range issue. The range issue, it's sometimes people say, well, that's more of a mental issue versus an actual issue. But the reality is the comfort level has to be there in that 300 to 400 mile range in order to enable people to then buy a cost-effective car that has that range and can charge that fast. So in order to do that, you can't just take what's been existing lithium-ion technology for the last 30 years. And yes, there's incremental improvements, and there's, some of those can be more significant than others, but you need to have a dramatic change in the battery architecture itself. And, from QuantumScape standpoint, doing a lithium metal anode that is pure lithium that is going to have much better performance, is going to be lower cost, and is going to be safer. That's another aspect that we haven't even touched on, is how much engineering goes into the safety aspects here. That we think is really going to enable mass market adoption, which is why, QuantumScape and others, there's such a massive effort on solid state batteries, as they're called, in order to do that. And part of the reason, we're working with folks like VW to, through a joint venture, to essentially scale this technology into the next few years.
I feel about that. I mean, your technology is, an additive, can be added to lithium ion standard current lithium ion battery technology. So, you can be used with current tech and future tech as well. What's your position on that?
Yeah, I mean, we batteries are good enough for a certain part of the market right now. We have sales in the Tesla vehicles, and VW and others are selling EVs right now. Now, the challenge, though, is we need to get to much higher ratios. I mean, we need to get, by the end of the decade, we need to get up around 30–40% of the new vehicles need to be EVs. And how do we get there? Initially, when I joined the battery industry back in 1991, we were getting improvements every year, 10–15% in energy density, and drops in cost of that scale. And now we're down like Asim is talking about the incremental improvements we're getting. He's absolutely right. We're getting like 1–2–3% a year at most improvements in energy density. It's not good enough to get us to that point of a high adoption rate by the end of the decade. So that's why at Sila, what we're talking about is our first generation product. We're going to get a 20% improvement in energy density. And we've got eyesight on getting up to 40–50% improvement in energy density. So we think by the end of the decade, using lithium-ion technology, you can probably double the energy density by the end of the decade. So that's so we think that's possible. We're enabling that, yeah. But there's also room for multiple players out there. So it's not one solution. The market is growing so fast. Multiple options are also available.
Yeah. Dustin, do you have something you want to add?
Well, I would say, I think electric vehicles for the consumer are looked at as a next generation product. And next generation products have to be seen as not having anything that's at least not as good as what they have now, right? And I still think, there's still some hurdles that you have to jump through as a consumer in some cases to really wrap your mind around adopting an EV. And we're working really hard to go after misconceptions, because there's a lot of them. One of the things that Asim said too is like range is kind of a mental barrier. And I think in many cases it is, but they're still there. And what we have to do is, with especially the battery technology, is make the promise of a next generation product really come to life. And in many ways, electric cars have. I mean, they're pretty more fun, faster. They've got better technology, all those things. But there's still drawbacks. And really the big thing that I think people get hung up on the most is the range, the cost, and the charging. So those are the three things that we're going to continue to tackle, because no matter if they're misconceptions or not, those are the things that keep people from adopting. And to really get to mass adoption, we've got to solve those three big areas.
Yeah. A little segue. I know you were telling us about your electric road trip across the country. You want to tell the audience a little bit about that?
Yeah, so I just did a over 7,000 mile drive from New York City to Sacramento, California, the long way. We drove, down through DC, then back up through the Midwest, Chicago, down through Florida, all over the place. And it was really just to show that, yeah, the capability for these things are there today. And you can drive an electric car like you do an ICE, and it's actually much more of a pleasant experience. And in the case of the VW ID4, I drive across the country for free because we include the fast charging with Electrify America in the offer that we have in purchasing the car. So we want people to understand very simply the benefits of that, because to do that drive in a gas car would have cost hundreds and hundreds of dollars. So it was more fun. We used better technology with some of the advanced driver assistance aids in the car, and it was free. So it's really talking about how we are tackling those three areas that limit adoption right now, because we want to do it. And then for me, I did a cross-country drive in an electric car in 2010 too. And just to show how much better it's gotten in 10 years. I used to have to stop at KOA campgrounds and charge the car and stay there for 5 hours at a time. To now be able to stop and, stop for 20, 30 minutes, take a bio break that you'd probably want to take anyways, back on the road. We've come so far. So the promise of this is really getting there, and consumers see it too.
Thanks for that. I'm going to take a question from the Q&A box. Thanks, Julia. Will future generation batteries be swappable with current EV batteries? Maybe let's look at the whole swapping issue. I know that's one that comes a lot for the battery industry. Thoughts on how interesting or doable swapping is for EVs?
I'm sure we'll all have an opinion. I'll chime in first. We tried it at Tesla, but we just found that the customers really didn't like it. You can imagine swapping. You leave your battery, which is the most important thing, making up 40% of the cost of your vehicle. You're going to leave it at some station for somebody else to get, or you're going to have to come back and get it afterwards. It just doesn't work. What really we need to focus on is the fast charge capability. Make it fast charge so it's really convenient, so you don't have to mess with the swap-in. That's my 2 cents on it.
I tend to agree on that. Kurt and I actually worked together for about 10 years. I remember that time quite well at Tesla. Very difficult thing to do. And then also customers really start to have a question of okay, which battery do I have? Is this, what kind of, usable life does this one have? Do I swap back to my original one? It's a logistical nightmare. So I think likely the easiest way, and really our investment at VW has been in Electrify America, and then charging also in China and Europe is really the focus.
Yeah, I think the part I would add is we talked about it earlier in terms of performance, but at QuantumScape, we're essentially working through aspects that can enable 4C charging, which means we've already demonstrated a less than 15-minute charge from 0 to 80% with our battery technology. So again, it's the charging experience that's the focus, because otherwise as they said, the asset change out type experience is a much bigger mental hurdle for people versus just fundamentally being able to go into a retail store and fast charge and go from 0% to 80% on the car.
Yeah, that makes sense. Another theme on our Q&A chat box is talking about the ability to recycle and have batteries used for second life on the grid. How are your companies enabling this kind of whole circular battery ecosystem?
Well, I think
Asim,
one of the.
go ahead.
Go ahead, Asim.
Oh, sure. So look, we're at a stage right now where we still are bringing the technology to market, right? We've tested the technology, bringing it to market, but a few thoughts there. One is that by fundamentally removing the anode altogether, you're essentially reducing the size of the battery and you're reducing the waste aspect to the battery. But the other aspect is what's the longevity, right? It's the same concept in terms of a circular economy. If you hold on to a piece of clothing for an additional year, you're essentially increasing and having a sustainability impact. Similarly, if you're going to have a battery that can go through thousands of cycles and can last a lot longer without degradation, it's going to stay in the car a lot longer, B, it's smaller, it doesn't have the anode aspect. And then there are some amazing efforts by folks like JV Swappable, et cetera, in Redwood Materials, where they can recycle the cathode aspect. So I think there's lots of opportunity to be able to do that, and there's some amazing work going on that front.
Yeah, I would just double up on that. Just focusing on the cathode is really important to get the recycling the cathode. There's also some copper and some aluminum in there as well in the foils. And when we were at Tesla, I led our recycling efforts there, and we were already recycling 60% of the batteries at that point. And now with Redwood and other companies out there, they're able to get recycle the metal, so it's not downcycling. It's recycling, it's using it back in batteries, which is fabulous. So you're not getting any losses on the metals. On the anode side, there's less interest in recycling the anode because it's really dirt, the graphite that's being used there now, and with ours, it's basically sand. So there's less interest in recycling of that. It's the metals that are the really, really important part. And the big thing is, if you do life cycle analysis on vehicles, about half on EVs, about half of the emissions are coming from the manufacture of the battery pack. So if you can reduce that, that's really critical. And so by using our material, you can actually reduce the total size of the battery pack by about 20%. So you can get a huge cut right there in your emissions, which is, as I say, it's half of the whole vehicle. So that's the way we're generally approaching it. And then the other thing is, we're trying to increase our lifetime. We're already over 1,000 cycles in auto applications, and we'll be able to get several thousand cycles. So by having the vehicle last a lot longer, like Asim is mentioning, that also just really helps on the environmental front.
Dustin, I think VW is pretty keen on battery recycling. I think I remember that from the Power Day.
Yeah, we in our first battery recycling center in Salzgitter in Germany. We'll look at further partnerships throughout the world. It's a responsibility of us. We're going to be the big consumer of batteries, so we need to have the responsibility on the back end to be sure that we're handling them appropriately and sustainably as well. So we're focused on that as well. The good news is, in most cases, that's a problem that will be down the road, but that could be a great advantage to us too, as we could potentially use some of those materials for other applications as well. So yeah, certainly looking into that, have a huge responsibility and are focused on it.
Yeah, what about in terms of second life, using the older EV batteries for grid applications and other applications? I think Asim and Kurt are a little bit farther away from that industry, but is this VW actively working on that type of technology?
Well, you saw that from our energy day, that we were talking exactly about how we can use some of those materials to get into some tertiary businesses. I think those are still pretty early days, given the kind of quantities that will get batteries recycled in are still pretty far in the future. But I think we're open to that. And given that we're a large consumer of these batteries, we have a huge opportunity there. So I think we're going to keep our eyes open to any possibilities with that. Yeah, certainly.
Okay. Are there anything from Kurt and Asim's perspective that you need to keep in mind in terms of the battery innovation or technology when it comes to second life batteries? Is there things you need to think about in terms of the design or packaging?
Well, yeah, I mean, the second life, with battery technology today, second life really doesn't make much sense. And the reason for that is, batteries, they generally get about 1,000 cycles, and you're at 200,000 miles or something like that. And the capacity drops. We've all witnessed this in our cell phones and our laptops. So it starts to degrade. You don't get the lifetime you got originally. The runtime drops. And at some point, it just drops off a cliff. And with a vehicle, if you're getting your 1,000 cycles at 200,000 miles, so your initial driving range is like 300 miles, for example. And then once it gets down to about 150 miles or so, and your vehicle's 200,000 miles old, it's kind of time to retire that vehicle. And the battery, there's not much left on it. And if you take that out and put it into another application, it's just really going to be hard to match it up, to use that effectively, safely, and to get enough lifetime out of it. The cost doesn't justify it. Now, in the future, once you get cycle life up there and greater than where we are now, instead of 1,000 cycles, if you get up around 5,000 cycles or 10,000 cycles, then it becomes much more interesting. Then you can talk about potential lifetimes afterwards, or more likely a lifetime of the battery while it's in the vehicle. You would actually use it you'd connect it to the grid, and you'd be doing vehicle to grid charging. There's all sorts of other applications that open up once you get higher cycle life, including using it for a secondary application.
Thank you. There's a couple questions on the chat channel about fast charging and battery degradation. I'm going to hand that one over to Asim. For current lithium-ion batteries or for QuantumScape's battery, can you talk a little bit about, you know, if fast charging leads to kind of greater degradation of the battery and how to solve that?
Yeah, so traditionally fast charging, you know, the reason that your car charges really fast in the uptick and then sort of it levels off on the charging speed, you know, is because of the limitations of the battery itself. If you hit the battery with too much power, it's going to cause what's called dendrites, which is like lithium crystals that form that essentially short circuit the battery. So to protect the battery, everybody has sort of either software or other ways that they limit the amount of current going into the battery. So from the standpoint, and the reason they're doing that is because if you think about a traditional lithium-ion battery, you're essentially, it's like loading passengers onto an airplane because they have to go fit in between the carbon atoms, right? Every lithium ion has to go sit between 6 carbon atoms. So one of the ways that we attack that is that we essentially eliminate that housing, and it's more like you can just create a solid plate of lithium so you enable that fast charge. So when you do that, you've essentially removed that bottleneck and you've reduced the likelihood that you're going to get a dendrite formation or a short circuit of the battery, and you can charge it a lot faster. That's essentially why we've been able to charge, you know, in the speeds that we have in that 4C level versus today it's like C/3, which is, you know, a 3-hour charge is more standard, but that's simply not good enough for mass adoption. So if we're thinking about future battery technologies, you have to have a way to not only fast charge quickly, but be able to do it consistently. Right now, some folks might fast charge once every 4 or 5 cycles. What you want to be able to do is have the battery be so robust that you can fast charge it again and again without getting a degradation in capacity. So for example, our charging for 1,000+ cycles was a 1C, 1C, meaning you fast charge it within an hour and you discharge it within an hour, again and again, in terms of what the testing cycle looks like of that profile, so that you get that experience. Fundamentally, when we actually integrate it into a vehicle, you're going to have a different experience where you can fast charge it both within 15 minutes or less than an hour, and discharge it as in like just fully, you know, drive the car probably harder. That's probably a much more robust cycle where you're discharging a 300-mile range in an hour. That's some pretty intense driving.
Yeah.
Yeah. If I could just add to that, I totally agree with what Asim was saying. You've got to get that fast charge up there. In that 15-minute is kind of a magical time, and I think Dustin mentioned that as well. That 15-minute. From either roughly 0 to 80% is what you're targeting. We're doing same thing at Sila. We're targeting the same thing, and the advantage that we have with our silicon material is the capacity is roughly 5 times greater than graphite, and so your anode layer is much thinner. It's basically 1/5 the thickness of graphite, and because it's so much thinner, your resistance is much lower, and therefore your charge rate can be much faster. So it's one of the advantages of going with a silicon solution on the anode. Totally agree. We've got to nail this fast charge.
Comment for me, it's just a chicken and the egg scenario, I think, that we've got, right? Because I think we'll solve that, and then to be sure that we have the sort of technology on the charging and capacity is going to be the next. How do we build enough charging stations to allow customers that don't have another means to charge the ability to do it? You see most fast charging stations today, 4 or 8 stalls. When 30, 40, 50% of cars on the road, that's just not going to cut it. And you're going to need more of them. And just the pure cost of putting in these stations is high. So we've got to, I think that's going to be the next problem. We'll get the technology there, but then how do you get, you know, the capacity for fast charging? So you're going to see that this adoption, you know, has some bumps in the road with that. I think most people will actually be able to charge at home and be fine, but you already see it with Tesla. You know, on a holiday weekend, you're trying to go up and down the coast of California, you might be waiting for a charging station. So I think that'll be the next kind of thing that we're gonna have to solve, is getting the infrastructure right too.
Yeah, I'm gonna change the conversation slightly over to manufacturing. battery manufacturing is largely happening in Asia right now. Is that a problem? And what do you think we should be doing about that? Who wants to take that one? Easy question.
Well, yeah, go ahead for it. Go ahead.
I would just say that ideally you would be co-located. So if VW is making their vehicles in the US, then having a battery factory next to them makes the most sense. I think we'd all agree to that. However, in manufacturing in Asia, now when I was at Tesla in charge of the cell procurement there, we were buying cells from Japan, and the cost of shipping is next to nothing. So it's not a huge issue to bring it in from overseas. But while saying that, I mean, it would be beneficial to have it here, to be co-located. I think the bigger focus is, how are those batteries being made? Are they being made with clean electricity or not? And the supply channels as well, are they being made with green electricity? So that I think is the more important focus than which country it's actually made in.
I know in terms of the Biden administration is clearly very focused on trying to bring battery manufacturing domestically and invest in different minerals as well in the supply chain. What do you think the DOE infrastructure plan can do for helping the domestic battery industry? Is it something that's exciting for you guys? I'm going to kick that to Asim.
Okay, sure. It certainly is exciting. I think at the end of the day, anything that's done that accelerates EV adoption will essentially create the ecosystem, right? So if the domestic car manufacturers also, who have already announced in a lot of cases that they are electrifying their production, as they go down that route, then there will be the ability to then, both have the battery innovation, which is kind of what we're doing at this stage and others are doing, where we have hundreds of people working on the battery technology itself. And then aspects of the value chain of the battery manufacturing can certainly occur here. So I think the more that there are enabling policies for the production to be encouraged locally for electric vehicles, which is happening with the GM and Fords of the world, combined with charging infrastructure being resolved, which will then further allow consumers to adopt. It's a little bit of chicken and egg. As soon as that push comes, every OEM in the world is going to want to have some control on their value chain in terms of the batteries itself, because you're replacing the powertrain capability completely, with the battery pack being the most important aspect. So I think it'll pull it along.
Yeah, Dustin, from your perspective, I know VW's investing a lot in battery manufacturing.
Mm-hmm.
What do you think in terms of the domestic supply chain and kind of the activity around that?
Yeah, we're there. I mean, we're going to be having a battery facility in partnership in the Atlanta area in Georgia, which is close by our Chattanooga factory, where we're going to be doing ID4 production in the U.S. So we're there. I mean, I think it's a commitment also to, when you're buying material from overseas and shipping it, that's not great. You want to have it close by. So it's just about, holistically throughout the entire life cycle of the product, from production all the way through recycling. The entire conversation that we've had today is to have a plan. And I think that's what we're putting together now.
Great. And we had Jigar Shah on yesterday, who I think is very keen on using U.S. DOE loans for new battery manufacturing in the U.S. So something to watch there. Awesome. A specific question for you off the Q&A channel. Could Volkswagen take QuantumScape's battery and manufacture it, say at like Northvolt, or are you open to working with other kind of battery manufacturers, or are you keeping that all in-house?
So just to kind of answer that question super directly, we've already announced that we're doing a joint venture manufacturing facility with Volkswagen. So that's going to be the first gigawatt-hour scale plant that we build into the 2024-2025 timeframe together. So we certainly, will be working really closely together in that respect. And, it will be a brand new facility that will be built. And we're gonna, be making the separators, the solid state separator, which is one of the most important aspects, but the entire cell integration, et cetera, will be done under the auspices of that joint venture. And I think we foresee that being really a model where you work really closely with the OEM, because what's been invaluable to us from a Volkswagen standpoint is them being part of the process and giving the feedback in real time in terms of the cell development process, the solid state separator, the performance spec. It's been a great collaboration in that respect thus far from a development standpoint, but taking it to the next level of manufacturing where they have far greater expertise and scale. Dustin can always comment on that. That enables a player like us to bring our technology to market a lot faster than we otherwise would have, and an OEM to be able to adopt and integrate that technology into their design cycle for their vehicles a lot earlier.
Dustin, do you have something you wanted to add on that?
No, I obviously agree, and thank you. But that's really our core competency in engineering, manufacturing, bringing the product to life. So in trying to accelerate those things, I think that's where we can really come into play, and what we're trying to do.
Great.
Yeah, if I could just add to that. So our approach is a little bit different in that we're taking advantage of the existing infrastructure, and so we're going to work with, and we already are working with the biggest cell manufacturers around the world, providing them material, and so they can make cells with their existing facilities. And we're initially targeting a production facility in the U.S. That's why we raised our $600 million in January, was to get us into production. Really, our first one is going to be in the U.S. in 2024. But our approach is let's make it available to everybody out there. All the cell manufacturers can use it with their existing facilities.
Interesting. Question from Sunil Paul. Hi, Sunil. Thanks for joining us. Lithium ion batteries improved rapidly when in consumer electronics with very short product cycles. What's happening with the pace of innovation as these batteries are moving to EVs? Is it moving faster, slower? What does that look like? Kurt, actually, I think maybe you could have a good perspective on that.
Yeah, it's interesting with the one of the things that's different is there's a lot of money now in the industry. I mean, in Silicon Valley and across the U.S., we've had lots of battery startups over the years that have not made it all the way to market, and one of the reasons is they ran out of money. So that's been one of the challenges, and I think what we've seen with QuantumScape and also with Sila, that we've both been able to raise enough money to get to that production state. So that I think is one big differentiator. And I forgot the main part of the question. I'm sorry. Can you say it again?
Yeah. So battery innovation happened really rapidly through consumer electronics with very short product cycles. But what happens when the product cycle is much longer with an EV? Yeah,
I apologize for that. You're going to get quicker turns of innovation. Bringing engineers together, and we were really successful at this at Tesla when we brought the Tesla and Panasonic teams together and work collaboratively on developing. And it's just like what happened in the consumer electronics industry. That's why the battery manufacturers are in Asia, because the consumer electronics manufacturers are in Asia. So if you get these groups together working really closely, you can just innovation is going to go that much faster. And so the vertically integrating makes sense as we work with battery cell manufacturers and really work closely with them, and as they locate in the States, you're going to see something very similar. So I think we're going to see that innovation go faster as we start to co-locate together, and Sila is going to take advantage of that just like everybody else is.
Okay, we only have a couple minutes left. I lost your audio, Kurt, for a second, but that's okay because we can hear you, and we only have a few short minutes left. But wanted to ask a question about for both QuantumScape and Sila, Silicon Valley has had a history of battery manufacturing being difficult for startups because of it's capital intensive and a variety of reasons. What has Sila and QuantumScape done that have enabled the company to get much closer to these commercial production goals?
So I think one thing is doing rapid R&D to get it right initially is kind of the way QuantumScape worked. For the first 5 years, we tested materials. We did over 2 million tests to get the electrochemistry correct, to kind of crack the code on the solid state separator itself, and then worked on how do you make this over the last 5 years, and call it, that was about a $300 million effort. And then we've been able to go to the public markets and raise over $1.5 billion in capital to go all the way through the production timeline, which is kind of what Kurt was referring to earlier in terms of raising the funds. So from our standpoint, getting the building block to be right. And then the other aspect is, again, having an OEM partner throughout the process to provide that feedback in terms of both as an investor and providing engineering expertise from Volkswagen from a commercialization pathway has been critical as well. So having the customer engagement early, and it's hard. I'm not gonna, look, I'm a clean tech veteran. This is not a journey for the faint of heart. Katie, you've seen numerous cycles, whether it's been fuel cells, whether it's been batteries. It's capital intensive. There's no two ways about it because we make stuff. It's not software, it's not the internet. We have to make stuff and manufacture stuff and scale. So I think now that the capital markets are reacting to the EV transition as a whole, and actually, you have enthusiastic investors who want to actually put the capital in to get this to commercialization, and the OEM sector signaling so strongly in terms of electrification that they've never done before. I think it does change the game.
Yeah, and if I could just add to that, because I think the money part is definitely there. The end customer, totally agree with Asim on that, those are both really, really important. I think the other thing that's different this time is approaching it right from the beginning a little bit differently. So we approached it as you've got to make a drop-in replacement. You can't require your customers to make these new huge investments. So that is huge. So there's to adopt is just very simple. The other thing is just make it so the materials are available in large quantities around the world to make it economical. So I think those are other things. And then another big one is to hire experienced people that have done this before, whether it's myself or whether it's like our COO. I mean, he grew SunPower. Bill grew SunPower from a couple of employees to 4,000 or 5,000 employees. He's done this before, and bringing in these experienced people also makes a huge difference. I think that's also important.
Yeah, I want to make a plug here. I know we're just ending, but I think across the sector we're hiring rapidly. So
me too. Us too.
For folks interested, I mean, we literally have situation where we need to hire hundreds of people over the next couple of years. So it would be please check out our website and apply. Shameless plug, but biggest issue, hardware engineering, all those aspects, we need folks. And getting experienced folks is huge.
Yeah, chemical engineers for us, mechanical engineers, go to Sila.
Yeah.
All right. Thank you guys so much. It was really great to have all of you on this session. You're so knowledgeable. Thank you to all the attendees for your great questions. They were excellent, and we really enjoyed spending time with you. Next up, if you go into the other sessions, we got a networking break, and then in about 30 minutes, we've got electric logistics and delivery that I'll be moderating about electric delivery fleets. So that'll be exciting. But thank you so much for this excellent conversation about the future of batteries when everything's electric. Thanks, guys.
Thank you.
Thank you.